Hi, I'm here with Kentucky Division of Water Dam Safety Program. My name is Beth Harrod. We're here on Red Lake FRS 12. This is a flood control structure here in Berea, Kentucky. And I'm here with my counterpart, Miss Marilyn Thomas.
My name is Marilyn Thomas. I'm an engineer with Kentucky Division of Water's Dam Safety Program. I am a 46-year veteran of the program, and I've seen most of the dams on the inventory in the state. We're going to talk a little bit about what our program does and what authority that we have, and then we're going to cover some of the finer points of the dam inspection. So let's start with Kentucky's Dam Safety Program. Now, we've had a program since the late 50s, early 60s that pretty much paralleled the Soil Conservation Service and their program with the PL 566 structures that were being built for flood control.
The Soil Conservation Service has transferred into the NRCS, National Resource Conservation Service, that we now work with collectively. Most of the dams that we're going to visit today are NRCS constructed dams. They have followed the design specifications and adhere to most of the maintenance conditions under NRCS. The regulations that Marilyn has spoken to have been constructed under a lot of those initial standards, but most of the maintenance practices and what we're going to refer to in regards to observations made during our inspections have been industry standards that have developed along the way. So these industry standards, coupled with actual maintenance conditions that are in statute a little bit, but are in statute, are what it is that the Dam Safety Program adheres to on a regular basis.
Since 1975, we have determined what a dam is by law. And the definition of dam by law is a structure that is 25 feet tall or impounds 50 acre-feet or more.
25 feet is from the downstream slope, the dry side as a lot of people refer, and it's a vertical height from the lowest point of the dam, the toe of the dam, which is usually the stream channel below the dam, up to the crest of the dam, which is where we're standing now.
Let's get a little perspective on what acre-feet are. Imagine the football field at Commonwealth Stadium on the UK's campus. That's roughly an acre. So put water in there a foot deep and you've got 1 acre-foot. Make water 50 feet deep in that stadium and you have 50 acre-feet, which is the cutoff for the minimum size of a regulated dam in Kentucky.
The frequency of our inspections is contingent on the hazard classification of each dam. So there are 3 hazard classifications. There's high hazard, significant hazard, and low hazard. All of the hazard classifications are dependent on what is impacted downstream in the event of a structure failure. So in the event of a structure failure, low hazard classification usually only affects the structure. However, it can affect some downstream activities, but that's typically agriculture, non-inhabited structures. Usually the focus is on only the structure being impacted. Significant hazard classification is assigned to a structure when the structure fails and it impacts major highways downstreams. There is minor damage to structures, could be minor damage to residential, could be minor damage to commercial. High hazard classification includes any failure which could result in loss of life. In the event of a high hazard dam failing, it's going to have severe damage to any residential structure, any commercial structure, and any infrastructure within a community. So within those 3 hazard classifications, the inspection frequency varies from high hazards are performed annually, significants are performed every 3 years, and then low hazards are inspected every 5 years. Within the Dam Safety Program, we regulate 981 dams. Of those 981 dams, just under 200 are high hazard dams. So we're performing annual inspections on each of those high hazard dams.
We are going to cover the inspection process in this video today, but we're also going to talk about the fact that the inspection process starts in the office before it starts in the field. So you need to go over your previous inspection reports, both from dam safety as well as from your own office. Make sure that the property owners are on board with you being on the property. Know your way in and out. Always have safety in mind, because these are structures where you can have slips and trips and falls. You can have interactions with animals. Take the inspection reports to the field with you. Take note of any changes that have been made, either good or bad, in these reports, and know what you're getting into before you go to the field.
And ask your experienced counterpart all the secret information that they know because they've been to the dam a whole lot more than you have.
And it may be over in the historical file section with Division of Water, and if you don't have all the information you need on hand in the office, you can call Dam Safety, and we can look up our historical reference files and tell you a whole lot of things about this dam that you might not know.
So standard practice for an inspection is that we walk across all the surfaces. We walk the downstream slope, we walk the upstream slope, and we walk the crest. And what we're looking for is any irregularity, anything that may be an indication of a structural instability. What we have here is we found a hole. What is given consideration here is that it can fill up with water. It creates a saturation, it creates additional instability, in addition to the fact that it's a danger. So like Marilyn was explaining before, we started our inspection process in the office, but then we come out here and we put on our bug spray as directed, and we get our rain gear on as best we can. And we go out and we start taking a look at the vegetation. So we're looking at the vegetation to ensure that there's good growth, good established vegetation on the structure. Additionally, we need to keep that mowed so that when we come out here to perform the inspections, we can get a good eye of what it is that we're looking for.
What we're generally looking for is a good dense grass cover. And what we like to see in the way of vegetative cover is a good side-forming type grass that will protect the surface of the dam from runoff. We recommend that the vegetative cover be no taller than 6 inches. We recommend mowing at least 3 times a year, more often as the cover grows.
We also recommend that you don't mow immediately following a rain event, because that would end up leading into rutting.
We insist that we keep trees off the dam because trees and tree roots cause a lot of problems. And those tree roots also provide cover for burrowing animals. So we need to be really careful about the kind of cover we have on the dam.
There's 2 categories when we talk about trees on dams. One of those categories are trees actually growing on the structure. And the Dam Safety Program will give the directive in the inspection report to remove those trees. The problem with trees that are growing on a structure, as I mentioned, the root system grows into the dam. So any water that has already been absorbed into the earthen dam, as it should, that's how it's designed, intersects with the root system from a tree. It creates a piping issue, and then water does what it does and it finds its way out. So the second observation that we make when we're doing inspections is looking at trees adjacent to the structure. And we recommend a 25-foot buffer. If we do see that we have overgrowth on the structure itself, we'll include it as a directive within the inspection report that you have to have a 25-foot buffer. Most NRCS structures are constructed for flood control, so that means that you're going to have a highly impounded area in the event of a heavy precipitation, and then the water's going to discharge, and so we're going to get a lot of activity on the upstream slope. What we look for when we're performing inspections is the debris line. We're looking to see how high the water got in order to be able to target our inspection area. What we're again looking for is any kind of slumps or slides that may occur, because once again, if you have a reservoir that's filled for a period of time, it can disturb those soils. Once again, we're looking for the good vegetated cover. Oftentimes we have control structures that are built with what's called a wave berm, and it's usually an 8 to 10 feet section that's level on the upstream side of the dam. We're looking at the initial elevation, which matches that normal pool. And again, normal pool is the principal spillway inlet where the elevation of the pool normally lies.
So one of the things that happens with wave action berms is that they will erode over time, but they are also friendly to burrowing animals. And I have noted this spot on this dam before. There's a sunken spot here, and down in here, that either could be just wave erosion, but I suspect that we've had some burrowing animals at some time or other, and very likely some muskrats right next to the pool, because the muskrats like to be able to swim to food, and they like to be able to swim back into their dens without running into predators. So this is something to watch for.
Good maintenance practices, as we've spoken to in regards to mowing the dam 3 times a year, also includes the entire normal pool elevation. So the existence of this tall grass and some of these bushes prevents us from being able to perform an adequate inspection. Something else that I find interesting is that you'll often find animal trails running from the location of the principal spillway up the upstream slope. What we always look closely at is the principal spillway inlet. What we have behind us is the principal spillway riser. The trash baffles are constructed at an angular position so that when the water rises, any debris that may collect along those trash baffles is going to fall off as the water discharges. You can also see that there's a valve stem. The valve stem is connected to a drawdown outlet that's located at the base of the riser. The division will oftentimes give a directive that the drawdown has to remain open if the structure is in a position that it requires maintenance because it has been determined to be structurally unsound. What we don't see is the valve wheel. Typically there is a wheel that's placed on the top of that valve stem, and by turning the wheel, you open the slide gate, the drawdown inlet, at the base of the riser. We're at Red Lake MPS 1, locally known as Owsley Fork. This structure was initially constructed to serve as a flood control structure in addition to the raw water source for the city of Berea. This structure was initially constructed to satisfy the hydraulic compliance conditions of a significant hazard dam based on what would be impacted downstream in the case of a failure. Since then, development has occurred, and now this dam is considered a high hazard dam because of the development downstream. The Dam Safety Program currently has an application to modify the dam. They're going to be raising the height of the structure. Also, within that application, they're going to address some other issues of the dam. One of those issues is seepage. So when we're performing our inspections and we're making observations of seepage, the first thing that we look for is the transition of vegetation. These are all taller grasses. However, you can see the difference between the browner tall grasses closer to the dam itself and then the nice green lush vegetation behind us. The green vegetation begins to grow because of the presence of water obviously in the ground that indicates a sign of the seepage. When you come closer, you can see that there's actually standing water here. When you make those observations, you want to see if there's any particles in that water.
One of the main causes of seepage in dams are charged lines that go under the dam. Now this dam in particular has a water line that is charged to provide raw water to the plant downstream. But a charged water line also has the potential to leak, and when they leak and the inside of the dam begins to be saturated, we see development of seepage downstream, and we can also see development of sinkholes on or near the dam. So we don't recommend charged water lines through the dam.
Other indications of seepage is the presence of crayfish. They like water environments. They have that more defined exit where it looks like a small pile of mud with the center circle right down the middle of it, and that's their entrance and exit. So when you see those, there's a good indication that you do have a seep. So what's going on below our feet is the outlet for the 30-inch line from the principal spillway riser upstream. Below, the spillway discharges, and when it is fully charged in the case of a heavy rain event, the water comes out, it hits the baffle wall, it shoots back towards the structure and then falls into the stilling basin over the end seal, and then once again more energy is dissipated before it discharges into the natural stream. In addition to the 30-inch line outlet, there's also two 8-inch corrugated metal pipe foundation drains on each side of this outlet structure. So when you're performing your inspections, you want to ensure that both of those drain outlets are clear. You want to monitor any flow that's coming from those drain outlets because those are what control any natural seepage in the dam. It gives the ability for the dam to collect any water and discharge out those foundation drains. You want to ensure that the outlet area of your principal spillway pipe is clear so that it can flow appropriately. You want to check the concrete condition of your outlet structure so that your baffle wall can function as intended. You want to make sure there's no material within your stilling basin. And then you want to ensure that your natural stream transitions appropriately. Sometimes in channels like this, beavers build dams downstream of the outlet structure. When that happens, the water gets inundated and then it sometimes submerges those drain outlet pipes and then unfortunately the principal spillway pipe. So we want to make sure that that natural channel stays clear as well. Most NRCS structures are designed with an earthen auxiliary spillway. We're looking for good vegetative cover.
We are looking for spillways that are free of debris, free of gouges, free of scour.
Usually the auxiliary spillway channels are constructed separate from the dam itself. So in other cases, when the erosion occurs from auxiliary spillway activation, it won't begin to affect the earthen dam itself.
We are on Big Bone Lick State Park Dam this morning, and we are examining the dam for some of the problems that have developed in the last few years. One of the biggest problems we have right now is cracking and settling of the upstream slope and the crest. But we also have depressions along the abutment of the dam on the left side. And we have a number of sinkholes that had opened on the dam in the past. After an engineering study, it's been determined that the dam cannot be repaired, and very soon we're going to have the lake drained and the dam removed.
As Marilyn mentioned, we have longitudinal crack on this dam that's indicating a form of a slide. So when you're performing your inspection, you want to take a look out and make sure you don't see any longitudinal cracks which run the length of the dam or any transverse cracks which run perpendicular to the dam. Transverse cracks aren't as indicative of a failure, but they do create seepage paths. Longitudinal cracks, on the other hand, like the crack we have here at Big Bone, means that there is an instability issue and that there's a sliding problem. When you're out and you see a longitudinal crack that's anything wider than 1 inch, be sure to call your engineer and then, most importantly, call your dam safety office. We're at Red Lake FRS 5, locally known as Floyd's Branch, and what we're looking at here is the debris pile located within the auxiliary spillway. The debris pile has been placed here at the inlet, likely for a purpose of convenience, but what that causes is erosion in the event that the auxiliary spillway is activated.
We also have on this dam some damage from dirt bikes and all-terrain vehicles. You'll see in the background a trail that comes down the face of the dam. That trail goes all the way across the crest and down the face of the dam on the far side. It has eroded. It'd be very difficult to try to repair that.
We hope this video has been helpful. If you do have any questions about your dam or any questions when performing your inspections, please don't hesitate to contact us directly.